I have some old power supplies and some chip-on-board LEDs laying around. Let's combine them to make a bright light source. Two challenges to solve though. First one is that these LEDs need 30 to 36 volts and none of my power supplies provides this. Second one is that these are 20 watt LEDs and they probably need proper cooling. To solve the first problem, I want to put some power supplies in series. This is what I have laying around. If I put these two in series, I can have 31.5 volts. As for the power, my reasoning is that the power supply with the lowest current rating is limiting the current. This current flows through both power supplies. At 31.5 volts, this would give me a total of 72.8 watts. Since the LEDs are 20 watts, I can drive only 3 LEDs with this combination. To solve the second problem, I thought I used this heatsink in combination with this fan somehow. Good, let's put it together. First I stick the power supplies together and make sure they don't come loose using tie wraps. Then I cut the power cords on the input sides of the power supplies, strip the wires and combine same color leads and ferrules, and use a regular screw terminal block to make from 2 cables 1 cable. I then cut the cables on the output side of the power supplies and strip them. I measure the voltages to check they are as stated on the labels of the power supplies. And then I first glue the LEDs on the heatsink using thermal paste. I glue on only 3 of course. Then it's time to get the fan ready. I cut the wires and strip them. The fan has 4 leads and works on 12 volts. If I connect the yellow and black one, it seems to go at max speed. I've read somewhere that the other wires have some inhibiting functionality. If you put PWM signal on them, you can reduce the fan speed. But I don't know the details. However, it doesn't matter. I don't think I will need this functionality. Fortunately, my Asus power supply provides 12 volts out of the box, so I don't need voltage conversion to drive the fan. I make the wiring like this. I connect the power supplies and solder the leads of the fan. Each time putting heat shrink on the joints, shrinking them with a lighter. I finally wrap the joints in self-amalgamating tape for protection. Then I mount the heatsink onto the fan using binding wire. I cut off excess and pull tight with pliers to fixate the hole. I tie wrap the soldered parts to the fan housing for strain relief, and finally I solder the power leads to the LEDs. Red is positive, black is negative. Each time I first tin a wire and then I tin a tab, and only then I connect both and let the solder melt to join wire and tab. Finally, I remove the fan grating, because it covers the holes that I need for making some improvised stands. It's important to create some space between the fan and the surface it's standing on to prevent the airflow from being obstructed. Let's see if it works. Yes, properly. And it doesn't seem to get warm. A downside though is that the fan makes quite some sound. Maybe next time I will use the inhibiting function of the fan anyway. For now, however, that was it. I hope you enjoyed this video. If you did, please don't forget to share, like and subscribe. And I hope to see you in the next one. Goodbye, guys.